This is the 7th video of the section, building a polynomial regressor. In the previous video, we learned how to build a ridge regressor. In this video, we're going to take a look at the polynomial regressor, how we can build it, and how to measure its accuracy. One of the main constraints of a linear regression model is the fact that it tries to fit a linear function to the input data. The polynomial regression model overcomes this issue by allowing the function to be a polynomial, thereby increasing the accuracy of the model. Let's consider the following figure. We can see that there is a natural curve to the pattern of data points. This linear model is unable to capture this. Let's see what a polynomial model would look like. The dotted line represents the linear regression model, and the solid line represents the polynomial regression model. The curviness of this model is controlled by the degree of the polynomial. As the curviness of the model increases, it gets more accurate. However, curviness adds complexity to the model as well, hence making it slower. This is a trade-off where you have to decide between how accurate you want your model to be given the computational constraints. So let's start. Add these lines to regression_multi_var.py. In this code, we've initialized a polynomial of the degree. Now we have to represent the data points in terms of the coefficients of the polynomial. This is the line of code. Here, x_train_transformed represents the same input in the polynomial form. And this is the data point. Now let's check whether it can predict the right output. The values in the variable data point are the values in the first line in the input data file. We are still fitting a linear regression model here. The only difference is in the way which we represent the data. Finally, we run this code. As you can see, this is close to the output value. If we want to get closer, we need to increase the degree of the polynomial. Let's go back to the editor and make the degree 10 and see what happens. Now, as you can see, the predicted value is much closer to the actual output value. Amazing. So in this video, we learned about the polynomial regressor. Awesome. In the next video, we'll apply the principles we learned to a real-world problem in order to estimate housing prices.